Josh Judd is the CTO for Warp Mechanics, and here he is, Josh Judd.
Hello. So we have, laser, good. So I'm going to talk a little bit about how we've used a Lustre ZFS hybrid in a production context for media and entertainment. So this is commercial Lustre, not HPC Lustre. We've been working with the media and entertainment industry since 2010, but mostly using Quantum StoreNext. So putting ZFS RAIDs underneath a parallel file system is our wheelhouse. Doing it with Lustre is relatively new to us, but we started doing it last year. I can't really talk about the specific customer. A lot of the Hollywood studios are quite proprietary about how they do things and so forth. So I can talk about how the workflow interacts with Lustre and how the Lustre ZFS hybrid provides an advantage for that kind of commercial environment. Now, we're doing something a little bit differently than Livermore is currently doing with Lustre ZFS hybrid. We're actually running ZFS as the RAID layer, not as a replacement for ext4 as the backing file system for the OST. We intend to do both ultimately. We were basically waiting for the ZFS Lustre stuff to get fully developed by Livermore, but in the meantime, we've been running ZFS as the RAID layer on a separate RAID controller. Essentially where Livermore had in their diagram the NetApp controllers, that's our ZFS layer. So we're going at it in exactly the opposite direction of Livermore in a sense. But ultimately, we do sit Lustre on top of ZFS, so the end result is very similar. The biggest problem with using Lustre in a media and entertainment customer environment is that the movie studios or gaming companies don't necessarily use Linux as a uniform operating system. In fact, there's a lot more Mac OS and Windows. So we've experimented with a few different modes of getting Lustre support. Obviously, you can do SMB or NFS, but we've recently started putting the client operating system as a virtual machine on top of a Linux layer running the KVM hypervisor. So the hypervisor layer can be a native Lustre client, which gets you considerably better performance than if you're just having a Windows box connecting to a gateway using SMB. So I guess the takeaway here is that somehow you have to solve the multi-OS support a little bit better than just throwing SMB at it. That approach doesn't work as well from a legal standpoint if you're using Mac OS. I know a number of people in the room use Hackintosh kind of approaches, but that's not something that we can sell because we don't want to get stomped on by Apple, which they will do. So what does ZFS get you in the media and entertainment context? Well, obviously the hybrid storage is a really big thing. The ability to use the ZFS L2 ARC feature to get a large amount of data cached onto SSDs. The ZFS intent log, or ZIL, vastly improves write performance. But surprisingly, I found that media customers reacted very strongly to the data integrity features of ZFS, the block level checksums. Now, anytime you're doing a big data style environment, you turn the corner case possibility of corruption into a daily event. So obviously having enhanced integrity features is a good thing, but media and entertainment customers usually just don't care if a red pixel is turned slightly pink, right? You know, like if you get a flipped bit in a movie, it's like, whatever. But so this is why I was a little surprised at how much they liked that feature. But apparently there's a lot of growing paranoia in the movie industry about how data corruption is going to start affecting the much larger and higher resolution movie formats that are coming out. So primary benefits are performance and integrity. Obviously, open storage overall lowers cost. So compared to OEM hardware RAID implementations, our ZFS controllers are vastly less expensive. So this isn't a marketing talk, but just the notion of using open software as your RAID stack does save money. Now, because we didn't have the ZFS on Linux stuff hardened and fully production supportable, we felt that ZFS was supportable on Solaris, since that's where it came from, whereas Lustre was supportable on Linux. So since we've been doing this for a year now, the question is, how have we been doing it for a year when these are kind of incompatible approaches? You could port Lustre to Solaris. I don't think any of us are going to go do that. That's not really my agenda. ZFS to Linux, we absolutely support doing this, but it wasn't there yet. And the other option is to use ZFS on Solaris as a RAID controller under Lustre on Linux. That's what we did. We essentially put ZFS RAID on a physically separate CPU-based RAID controller, hooked it up using RDMA to the object storage server. So you get RDMA performance, direct connect RDMA performance from a pure Lustre on Linux to a pure ZFS on Solaris. So you get the fully baked and hardened ZFS and the fully baked and hardened Lustre with very tightly coupled performance between the two, yet enough separation that you don't get bugs from one bleeding into the other, I guess you could say. So that's why we focused on the third option. We think ultimately the ideal architecture for us would be doing both, having ZFS on the OSS to provide the benefits Livermore talked about, larger OSTs, etc., but also having the ZFS RAID on the RAID controller layer. So how does that actually look? Multiple RAID boxes hooked up to multiple HA-OSS pairs with a direct connect from each RAID controller to an associated OSS. Within the RAID box, you get ZFS intent log for write acceleration, L2 arc for read acceleration, and in our box, this is like a 4U box, we can fit an additional 200 terabytes of hard drive capacity. So you get the accelerators, and you also get the hard drives, 200 terabytes in 4U. It's a fairly dense solution, which is also very important for the media and entertainment customers because of some fairly aggressive advances in movie resolution associated with 3D and 60 frames per second and so forth. They're really looking to get the highest density they can possibly get while still maintaining performance. So what does that look like in this particular customer environment? Unlike traditional HPC systems, a large file system for a commercial customer is not usually going to be tens of petabytes. So the scalability goal is well within Lustre's capability. This particular file system is about 3 petabytes, and that's considered, quite large. Advantage to us of going to Lustre and away from Quantum StoreNext is that StoreNext kind of falls down after the first petabyte. The metadata performance just right. Whereas these days customers need to exceed a petabyte and are moving towards tens of petabytes over the next couple of years. We don't really think that Quantum StorNext can keep up with that scalability requirement. But this is really the big win for media and entertainment in combining Lustre with ZFS. In order to get really good random read performance out of Lustre is kind of difficult. It's really good at sustained writes, not necessarily as good at sustained random reads, particularly if some of them are small I/O. So using the L2ARC feature of ZFS, we're able to get a very large amount of data onto SSD. And this is managed automagically with some minor enhancements we've done to the ZFS caching algorithms. So you can, in fact, send various real-time kernel tweaks at the ZFS layer to change how it's injecting data onto the L2ARC SSDs to make it, probably 95% hit rate on read cache hits. So basically the hard drives become almost an HSM solution in that you're writing to the spinning magnetic stuff, but you almost never read back off of it, right? So the challenges moving forward, well, there's the continual ingest of large files at high speed, but that's not really outside the standard Lustre wheelhouse. So the question is, how do you simultaneously have large random reads of the file system that's continuing to get the large sequential writes? And this is where the L2ARC stuff comes in. Current architecture is fine for that. We're getting apparently my laser is okay. Tens of terabytes per project. The number of projects currently on the file system, it works out well to keep the entire working data set on SSD within the warp rate arrays. But the movie industry is moving towards 60 frames a second, 3D, so 2. And higher resolution per frame. It basically adds up to a couple hundred terabytes for a single movie before you've done special effects, before you've done sound editing and so on and so on. This is where we will be enhancing it by putting additional SSDs into the OSS themselves. So we think that the ZFS L2ARC capability is very interesting, but we also are any of you guys familiar with the Facebook Flash Cache software? So we think that integrating Lustre with Flash Cache is really how you're going to get the much larger read caches in OSSs. Okay, so that's how you basically handle read caching. Within this media system, we have 10 terabytes of ZFS L2ARC currently in each 4U enclosure. Together, well, after RAID overhead, it's 150 terabytes usable capacity. So that gets you, 10%, little less than 10% of your total capacity on RAID optimized SSD. But when you move to those larger movie formats, you're going to need essentially flash cache SSD within the OSSs as well to get the SSD read cache up to a large enough level. Okay, so how does this net out? We get random reads to accelerate with SSDs. We get ZFS kernel tweaks to make that useful. If all you do out of this talk is turn on L2ARC, I should warn you it's not going to do anything really useful. The ZFS default algorithms for using the read cache SSDs just don't do anything that most customers would benefit from. Okay, so the full system looks like this. High-speed data sources, movie cameras, things that don't have Lustre clients. I would like it if movie cameras had Lustre client, but they don't. So those have to go through Lustre client gateways to write into the file system. The L2ARC kernel tweaks essentially prioritize getting all of the writes onto SSDs immediately instead of just a certain percentage of them. And then, scales out pretty much as you want. This particular client only needed 16 OSSs. So, how does this really help the movie industry? Well, there's vast cost savings. I mean, I don't want to kind of get into specifics since this isn't a marketing pitch, but open storage as a RAID controller does save a lot of money. And if you're buying petabytes and petabytes and petabytes of data, it adds up pretty fast. But this gets you a set of features that are superior to most commercial hardware RAIDs. As the Xyratex person pointed out, the software RAID community can always out-innovate the hardware RAID community, because in hardware RAID, you have to wait a year and a half to spin a new ASIC every time you want to add a feature, whereas software, you just install a new package. So it gives the movie-making community advanced features at a lower cost. Now, it would be one thing if they just pocket the money and call it a day, but I think the best way to do it is to spend that on more solid-state disks for read cache and more NVRAM modules for the write accelerators. We don't actually use SSDs for the ZFS intent log. We found that was a bad plan. They tend to burn up. So we actually use NVRAM modules that are in a SAS hard drive form factor. It's basically DRAM with a battery. Well, it's not a battery. It's a supercap and enough capacity in the capacitor to hibernate the DRAM onto an internal SSD if the RAID crashes. Okay. All right. So in the 3 minutes before lunch, we have a question.
Thanks. I was just curious. In several of your slides, you showed the RDMA between the OSS and the ZFS RAID appliance, if you want to call it that. That's SRP over InfiniBand, or what is the?
Yes. It's a direct connect. Currently, we're using QDR InfiniBand. From a performance standpoint, going to FDR didn't buy us anything, and the driver support for the Mellanox QDR card is better in Solaris at this point. So the question was, since we're not on the microphone, Solaris is providing the SRP target. Solaris, per se, doesn't. Comstar does. So, but the base OS on which we're running Comstar is Solaris, and that's where we get the QDR HCA driver.
So I see you mentioned Linux in KVM as a way to kind of send data to your Windows clients, and also something about this not working on macOS. I'm not sure why. But did you look into the liblustre? It certainly works as a client on macOS, and you can marry that to Fuse, and then you will have a native file system on your Mac client without any virtual machines and stuff. And in addition to that, liblustre actually kind of, you can run it in embedded environments. Cray certainly did it before, so that might be your camera solution.
Okay. So I would suggest you stop by the Warp booth over there during a break, since that's way more detail than I can talk about in 30 seconds. But the short answer on why macOS isn't supportable on that, it's nothing technical. It's that Apple states that you're in violation of your support license and their copyright if you put any form of Mac OS on any hardware other than Apple hardware. And there have been recent court cases in which they asserted that and won. Essentially shut down vendors who were trying to put Mac OS onto non-Apple hardware. So for a government-run supercomputing lab, maybe you have the resources to fight that particular legal fight and win, but a vendor such as myself has to be a little more careful of violating others' copyrights. So,
All right. Thank you, Josh.
thank you.